If you buy a fully assembled 3D printer, you'll probably get a power supply like this that's in an enclosed case, or the power supply is built right in the machine, so it's a lot safer. But if you get one of those low-cost kits, they'll probably send you one of these metal power supplies with the wires all exposed, and they don't always tell you the proper way to wire it, which is very important. Well, I want to talk about a few recommendations to make your 3D printer safer electrically on today's Filament Friday. Filament Friday is brought to you by the generous donations of my Patreon supporters. Please consider donating $1 a month to keep Filament Friday going. These are two printer kits that I actually put together. One is the TiVo Tarantula that I paid $230 for on eBay, and I bought it just mainly for the parts because I wanted to build a bigger printer, but I ended up putting it together and it printed halfway decent. I was pretty happy with it. This is my Maker Front, which was donated to the channel many months ago. And it was a little tough to put together at first, but once I got this thing together, it's been a great printer. Prints really, really well. Now I'm in the process of making it even better with a few modifications, but it's been really reliable for the channel. Now these two came with two different cords, and it's really interesting. Both of them, there's room for improvement. The TiVo, and this is very common with a lot of printers out there, it came with a 2-prong cord, which you really want a 3-prong. It's 2 prongs, and it comes with a blue and a brown wire, and that's actually the European wire code, blue and brown. I'll explain the US in a minute. The Maker Front came with a 3-prong cable, which is what you want, and it came with a color code, green for the case ground, but 2 black wires, which it should have been color coded differently. So that is a little bit of a drawback. What you really want, and you may require you to buy a separate cable for your printer, is you want a 3-prong cord, at least in the US, with green, white, and black wires. That's the proper color code, so you can get this thing wired properly. The color of these wires are very important. The black wire in the US color code is the live wire, or the hot lead. This is where it's 110 volts. Outside the US, this would be brown and 220 volts. The white wire in the US is your neutral, and somewhere along the electrical system it's connected to an earth ground, and they do that for any static buildup that's in the electrical system. It gets discharged through that earth ground. This would be a blue wire outside the US. Then you have the green or ground wire, and this is a case ground, and this one goes to that little round metal prong on the 3-pin plug. This is there to connect the case of this power supply, or if it's connected to a refrigerator or toaster, the metal case is connected to that green wire, so that way if there's ever a short of that black or brown wire inside this giving live power connected to this metal, it'll go through that green wire to earth ground instead of going through you if you touch the metal. So on the power supply, it'll have 3 markings, an L, an N, and a ground symbol. The L is the live, and that's where the black or brown wire will go. N is the neutral, and that's where the white or blue wire will go. And then the ground symbol is where the green or green with a yellow stripe will go. And it's very important to get those right, because that ground actually connects to this metal case. So that way this case is now connected to earth ground when you use that 3-prong plug. If you connect only a 2-prong plug, you don't have that connection to this, and this could potentially shock you if the wires were to short out and touch this metal. So it's still pretty safe, but it's extra protection by having those 3 prongs. Now it goes a little further. If you have a 2-prong plug like was on the TiVo here, it should have one wider than the other. And that's because the wider plug, at least in the US, represents the neutral, the one that's connected to earth ground. So that way when you plug it in, you're plugging in the proper way. So in this particular case, you got a brown and a blue because this is European. The blue should be connected to the wider terminal on an AC plug. So at least at that point, you've got some electrostatic charge protection. If you get them backwards, you're really messing up the system. And that's why you want one bigger than the other. But it's best to have the 3 prongs because then you get that grounded case. And that's where some people really mess up. They'll have a 3-prong like this, and they'll either break that prong off so they can plug it into an old 2-prong system, or they'll use one of these adapters. They'll plug it in, and now it's 3 down to 2. They've just disconnected their case ground. Now there is a little ground thing here that's supposed to screw into the case on the wall, or the plug on the wall, so you get a proper earth ground. But if that isn't connected, this thing is no longer has connection to the case, and now this case can actually shock you if a wire should ever short inside of it. Now many people take these power supplies and they'll 3D print a nice end cap on it. So that way the wires are covered and protected. In fact, they'll even put a plug on the end of this thing so they can plug in a 3-prong cable. And that's a good idea. But it still leaves the rest of the box exposed. So you hope they have a 3-prong cable that's connected properly. And that's a very good step in the right direction. But I wanted to go further. So I took this, which I found on Thingiverse, and I modified it in Tinkercad so it was a full box. So it covered the power supply in all directions, and then a second box to cover the other half. Now I have a fully enclosed power supply. And I've got ventilation holes designed into it, even on the end where the heat sink is. And I got a switch and a plug with a fuse. So this can mount right on the side of this, and even if somehow that case ground gets disconnected, I'm not going to touch it and get shocked. This is a very safe way to handle your power supply. This box was designed to accept one of these modules that has a 3-prong plug, a inline fuse, and a power switch. And it just snaps in place. What I found though is most of the ones you'll buy on Amazon or elsewhere are 10 amp modules, meaning they have a 10 amp fuse and 10 amp capability. But when I dug deeper into the schematic of the ramps board on this guy, which has an Arduino and a ramp shield, I started to question if that 10 amp was the right size, even though a lot of people are using this. And some people have commented that the module failed. Well, maybe it was because you're pumping too much current through it. Let me show you what I found by looking at the schematics of the ramp's shield. So here's the ramp schematic. This is the shield that plugs into the Arduino Mega and controls most of our 3D printers. Sometimes this is built into the board with the Arduino, and sometimes it's a separate shield, but the schematic is basically the same. And we've got the thermistors, end stops, heater, stepper drivers, power, and this power is the area I want to focus on. So to determine my fuse, I wanted to see what fusing was in this guy. And there's 2 lines, 2 12-volt lines. One goes to a 12V label, and one goes to a 12V2. If I follow the 12V, that controls all the stepper drivers, also the hot end and the fan. So all those are controlled by this 12V line, which has a 5 amp polyfuse here. The other one, V2, goes to the FET here that controls the heated bed. So this is V2, that's on a line all itself. And that's got an 11 amp polyfuse. Now what are polyfuses? They're basically resistors that change resistance with temperature. And these are PTC, that the positive temperature coefficient, the resistance goes up as they get hot, which is kind of opposite of what a thermistor does. A thermistor is a negative temperature coefficient, or an NTC. Its resistance goes down as it heats up. And the thermistors give a variable resistance, and that's what the Arduino reads to determine whether to turn these transistors on or off to control the temperature of the hot end or the heated bed. So these being PTC, what happens is they heat up at a certain current equal to that heat, they've been calculated. They go to real high resistance, or almost an open circuit. So that's why they're resettable fuses. And then once they cool down, they go back to low resistance, and they've reset themselves. So combined, 11 amps and 5 amps, that's 16 total amps this guy, worst case, can draw, because then these kick in. So I don't want to go worst case, because I want to trip before they go. But I want to supply enough current that any surges for the heated bed or anything, that it has enough current. So anything less than 16 would probably be good, but I don't want to go too low, because then the fuse is going to probably trip at times. So I'm going to go just below these combined at 15 amps. That way each individual circuit has plenty of current to work, And if one of them gets a short, the fuse can do its job, the resettable fuse. But if both of them have a problem, there's some short, major short, then my fuse will trip at 15 amps. So that's what I'm going to shoot for, a 15 amp fuse. So once I figured out that I needed a 15 amp setup, I found one online at a reputable company that I've bought a lot of electronics from, and it was a 15 amp module. And when I got it, just to verify, the switch, which was already snapped in, I popped it out and found out it was only rated to 12 amps at 125 volts and 6 amps at 250 volts, even though it said it was 15 amps at 250 volts. So I've contacted the company. They're digging into it deeper because they're not the manufacturer, but I can't use this in my setup because if I have a 15 amp fuse and only a 12 amp switch, the switch is the weak link. The switch will burn up before the fuse. And what's the point of having a fuse? So just adding a switch to your printer sometimes is just not as easy as buying a little module on eBay and connecting it all up. You want to make sure everything is the proper current rating. So I wasn't able to get a replacement switch in time for this Filament Friday, but I'm really happy with the way the print turned out. So I'm closer to getting this guy done with the proper setup. So that's all I could do for this one. When I get this figured out, I'll show you that in a future Filament Friday. So I hope that helps you to build a little bit safer 3D printer. If you like what I'm doing here, maybe check out some of my other videos over here. And if you want to help support the channel, click on Patreon. $1 a month goes a long way. And 60% of the people who've been watching my channel over the last 60 days are non-subscribers. So please click on that logo and subscribe. It helps out a lot. I'll see you next time on Filament Friday.